So we want to estimate the correlation between monthly news and the government corruption and government's popularity using a time series monthly data set. Okay, so the first thing to realize is it's time series, okay? Time series. What does time series mean is that I'm only looking at one individual, our government, over time. Okay, just one individual. The variable news and popularity are continuous variables. We believe that the relationship between these two variables is not linear and may not even be monotonic. So you really have two problems in your modeling. One is that the model is nonlinear, and two, that the model is non-monotonic. Now, to answer that, you need to kind of understand what's the meaning of nonlinear and what's the meaning of non-monotonic. So let me try and give you a visual for those. So before I kind of answer here, imagine that here you have your y variable, which is popularity, and you have your x variable, which is news. The first problem of nonlinearity means that you might have things that look like this. Okay? When we fit regression lines, we ideally want to fit lines, but this is problem one. Problem one. So the function is nonlinear. So the line that you might want to try and fit might not be linear. Okay? This is problem number one. What's problem number two? Problem two. Well, it's non-monotonic. What does non-monotonic mean?
It means it can have the same value twice.
Okay, non-monotonic means that it doesn't always increase or always decrease. When you fit a line, when you fit a beta line that is linear, let's say like this, it's always increasing in x. Non-monotonic might mean that perhaps between these two values it is increasing, but in these values here it is actually decreasing. This is a non-monotonic function, so your data might be like this. So the question says, suggest two empirical models to estimate the relationship of interest. Okay? How do we deal with each problem? Here's how we deal with nonlinearity. We always introduce nonlinear terms. So instead of running just a regression on popularity, alpha plus beta news, or beta 1 news, I could add nonlinear terms, plus beta 2 news square plus beta 3 news cubed. How do I know when to stop? Because I haven't been told anything about the degrees of linearity. Generally, you would stop where any of these coefficients become statistically insignificant, right? So the cube of news might be statistically insignificant once I have the square and itself. Okay? So that's one way that you could fix, or you could try and address this problem one. So if assumption one does not hold, or the line that you're trying to fit is not linear, what's the solution? Add nonlinear terms. Okay? Yeah.
Don't you run the risk of overfitting if we add too many?
Of course, yeah. So if we had too many variables, we run the risk of overfitting, right? Is this idea of, especially if you have relatively few observations and a lot of x's or a lot of betas, then effectively you're not really going to get something very meaningful. Okay, so this overfitting problem is when you're too zealous adding things. Okay, but for now, for the purpose of this question, just realize that to fix this, add nonlinear terms. That should have been the one line, if you like, summary of that problem one. Okay? What about problem two? How would you fix problem two? Yeah.
Maybe add terms B2 and B3 to be negative?
Not quite. So one answer is maybe allow for beta 2 and beta 3 to be negative, or to have a hump shape. How could I deal with this situation? You will more formally learn about this through the use of dummy variables, which we haven't yet talked about. But just by looking at that, if the problem is non-monotonous, you could have divided your sample into this and call this sample 1, and this, and call this sample 2. So you could have run a separate regression on sample 1 and a separate regression on sample 2. So, what would have been a good exam answer or the ideal exam answers? Jordi has provided some ideal exam answers on all of the 2018 questions. So it's a really great paper to go back and use it as a source of learning. Because not only do you see the ideal answer, but you also see what sort of things students get wrong. Okay. This could have been a very quick answer. Like for your exam, you don't need generally more than 3 or 4 lines to get full marks. In here, you'd have said the way we deal with nonlinearities is adding non-quadratic terms. The way we deal with non-monotonicity is by carefully subdividing the sample into subsamples. Later on, you'll be able to see that that would be done with dummy variables. So that's all I have for this question here.